So here we're going to look more at the algebraic equations without so much of the context here, but just kind of looking at the formulas. So, there's different ways to find the ordered pairs in order to draw the graphs. So, for instance, if you have this equation, x plus y equals 5, you might be able to just come up with some ordered pairs very easily just by thinking about numbers that make it true, because this equation is pretty easy. So something like 1, 4, 2, 3, and say 6, -1, right? These would all be ordered pairs that satisfy that equation. However, sometimes it's easier if you find y by itself, so then you can kind of pick values. So if I were to subtract x from both sides, you would get y equals -x plus 5. And in that case, you could pick values to plug in for your x, say 0, 1, 4, it doesn't really matter. You could just kind of pick different numbers. And then if you plug them into your x, and then you can just evaluate that. So -0 plus 5 would be 5, right? -0 plus 5. Or if you did -1 plus 5, that would be 4. Or if you did -4 plus 5, that would be 1. And so we can get our ordered pairs that way. Sometimes it's also helpful to find your x and your y intercepts. So if you're going to try to find your x-intercept, you just plug in y to be 0. So x plus 0 equals 5. Well, then that gives you x equals 5. So that would be 5, 0. So that would be your x-intercept. And for your y-intercept, you could let x be 0, 0 plus y equals 5. So that gives you y equals 5, 0, 5. And any one of those, you can kind of draw that graph from those ordered pairs. So let's try one that's maybe a little bit trickier, because this time 2x plus y equals 5. That's a little bit harder to do that kind of just thinking of numbers. So let's do one of those methods where we get y by itself. So take away 2x from both sides. That gives us the equation y equals -2x plus 5. So if I were to pick some x values to plug in, 0, 2, 4. You can kind of just pick whatever you want here, especially with the whole numbers. Don't have to worry too much about it. If you plug in 0, you get 5. If you plug in 2, that would be -2 times 2 plus 5. So -4 plus 5 would be 1. If you plug in 4, that'd be -2 times 4 plus 5. So that would be -8 plus 5, -3. So now we can draw our graph based on these values. So let me draw my axis here. Notice I'm trying to draw them. I'm a little crooked, but it's harder to draw on an iPad than it is on paper sometimes. So 0, 5 be up here. 2, 1, and then 4, -3. And for linear equations, if you plot 3 points, they should all fall in a line there. So if you get one that's kind of scattered, it helps you know that you might have been off track. Whereas this other one, the second one, we did the slope-intercept method because that worked out nicely. Or if it's a super simple equation, you can just kind of guess some numbers and make it work. Right. So let's look at this one next. This one's actually even a little bit trickier because if I were to try to solve for y, things don't divide as evenly in this case. So if I were to take away 2x, here you would get 3y equals negative 2x plus 5. And then if you divide by 3, you have to do that across all the terms. That would give us y equals negative 2/3 x plus 5/3. Now this one's a little tricky because we're trying to get our numbers to be like whole numbers that we could kind of plug in and get whole numbers back, whereas this is going to lead to a lot of fractions. So this one could get a little bit tricky. So in this case, you might want to try that x-intercept method. So let's review that. I did it quickly before. I'm going to do this in more detail this time. To find the x-intercept, remember the x-intercept is where it crosses the x-axis. So that would be, oh, where does it cross the x-axis? Well, if it's on the x-axis, that means it's not up or down, so y equals 0. So in that case, to find the x-intercept, I'm plugging in 0 for y. So that would be 2x plus 3 times 0 equals 5. So that's 0 there. 2x equals 5. So we get x equals 5/2 or 2.5. Okay, so again, not getting us whole numbers, but 5/2, 2.5, not too bad to work with there. Now the y-intercept would be, remember that's 0 y, because when you're on the y-axis, that means the x is 0. So this time that would be, well, 2 times 0 plus 3y equals 5. So divide both sides by 3. You get y equals 5/3, or this would be 1 2/3. Okay, so again, given us a fraction, I'm going to zoom out a little bit to kind of draw a graph based on this. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so let's plot those points. The x-intercept would be from here. That would be 2.5, 0. Remember the 0 there. So 2.5, 0. The y-intercept would be 0, 1 2/3. So 0, 1 2/3. So not quite the middle, a little bit above. And then we can draw our graph that way. Should be about like that. And actually, if you notice, our slope-intercept form that we had here that we thought, that might be tricky, I think you can kind of see, look, here's the 0, 5/3. That's that y-intercept that we found, okay? And then if I go down 2 over 3, I should be on the line. It's not going to give us that exact point that we found because that would have been down 1 2/3. But if I go down, look, if I go down from here, if I go down 1, 2, and then over 1, 2, 3, I'm right over here on the graph. So I kind of find that that is another point on the graph as well. Okay. So those are a couple different methods for graphing the lines. Just to recap, this one we use the x and y intercept method.